Just like post in the chat box. What are the things we require? Just a minute. The first thing what we require is concepts of soft computing. Soft computing concepts, types of soft computing techniques. Just I will share my screen to revise the important things. Then we will go through the next presentation. Just I want to share my screen. Introduction to soft computing, types of soft computing techniques. In the introduction part, we meet the structure, objectives, computational paradigm, soft computing versus hard computing, soft computing, premises of soft computing, guidelines of soft computing, uncertainty in artificial intelligence, applications of soft computing, summary, and then review questions. In the objective of soft computing, you should learn difference between hard computing and soft computing, reason for why soft computing is evolved. At the end, some applications of soft computing will be discussed. Okay. Computational paradigm is classified into hard computing and soft computing. Hard computing is the conventional computing. It is based on the principle, precision, certainty, and inflexibility. It requires mathematical model to solve the problems. It deals with precise models. This model is further classified into symbolic logic and reasoning and traditional numerical modeling and such methods. The basic traditional artificial intelligence is utilized by these methods. It consumes a lot of time to deal with real-life problems, which contains imprecise and uncertainty information. The following problems cannot be accommodated with hard computing techniques: recognizing problems, mobile robot coordinating forecasting, and combinatorial problems. Soft computing deal with approximate models. This model is further classified into two: approximate reasoning and functional organization. Random search methods. It handles imprecise and uncertain information of the real world. It can be used in industries, in all industries, business sectors, to solve the problems. Complex systems can be designed with soft computing to deal with the incomplete information. When the system behavior is not completely known or the existence of measures variable noisy. Soft computing versus hard computing. Hard computing. The first point in the hard computing is it precisely stated for analytical model. Soft computing, it is tolerant to imprecision, uncertainty, partial truth, and approximation. Hard computing is based on binary logic and crisp systems. Whereas soft computing is based on fuzzy logic and probabilistic reasoning. Soft has a future precision and categoricity. Okay, that is a future for hard computing, but soft computing has a features of approximation and disproportionality. Soft computing work on exact input data. Okay, whereas hard computing work on the exact input data. Whereas soft computing can work on ambience and noisy data. Hard computing performs sequential computation. Soft computing performs parallel computation. That's most important. In hard computing, it performs sequential computation. Whereas in soft computing, it performs parallel computation. Hard computing produces precise outcome, whereas soft computing produces approximate outcome. This is also important one. It produces precise outcome. Whereas soft computing just see here. It produces approximate outcome. Okay. The real world problems require systems that combines knowledge, techniques, and methodologies. It's like expertise within specific domain, adapt themselves, and learn to do better in the changing environment and explain how they make decisions and take actions. Natural language is used by human for reasoning and drawing conclusion. In conventional artificial intelligence, the human intelligence behavior expressed in the language form are symbolic rules. It manipulates the symbols on the assumption that such behavior can be stored symbolically structured knowledge base known as physical symbol system hypothesis. Just observe that. Basically, soft computing is a homogeneous body concepts and techniques. Let's observe this line. Homogeneous body concepts and techniques. Okay, soft computing combines different techniques and concepts. It can handle impression, uncertainty for zero computing, generative programming. Computing the fields of soft computing. This is a very important concept. Of course, it's the heart of this concept is symbolical manipulations. The main computing paradigm of soft computing are fuzzy systems, neural networks, and generative algorithms. This is the main concept. Fuzzy sets are knowledge representation via fuzzy rules, neural networks for learning adaptivity, and genetic algorithms for evaluation and computation to achieve resembles with human-like decision making. Soft computing aims to explicit tolerance for approximation, uncertainty, impression, and partial truths. Approximate the model has similar features but not the same. Uncertainty. The future of the model may not be the same as that of entity impression. The model features qualities are not same as that of real ones, but are closer to them. Premises of soft computing. The real world problems are imprecise and uncertain. Precision and uncertainty carry a cost. There may not be precise solutions for the some problems. The guidelines principle of soft computing is to exploit the tolerance for approximation, uncertainty impression, and parallel truth to achieve tractability, robustness, and low solution cost. Human mind is the role model for soft computing. Uncertainty in AI. Objective features of old environment. There are a lot of uncertainty in the world. We have limited capabilities to sense these uncertainties. Subjective features and interaction with concerned environment. A same similar situation, people have different experience. This experience maps on the futures of scenario of different languages. Applications of soft computing. The applications of soft computing has proved following advantages. The applications that cannot be modeled mathematically can be solved. First point. The second point is nonlinear problem can be solved. Third point is introducing human known knowledge such as cognition, understanding, recognition, learning, and other fields of computing. Few applications of soft computing are handwritten script recognition using soft computing, image processing and data compression using soft computing. The next one is use of soft computing in autonomous systems and manufacturing. Soft computing based architecture. Soft computing and decision support system. Soft computing techniques and power system analysis. Soft computing techniques in biometrics, bioinformatics, Soft computing in investment and trading. You must know about what is computational paradigm, state difference between hard computing and soft computing, write a short notes on soft computing, what are the premises and guidance principles of soft computing, techniques, give any three applications of soft computing. You must know about that. Coming to types of soft computing techniques, what are the objectives, types of soft computing techniques, fuzzy computing, neural computing, genetic algorithm, association memory, adaptive resonance theory, classification, clustering, probabilistic reasoning, Bayesian network, summary. These are all pillars for the subject for our next continuation presentation. That's why the reason I'm reviewing all those concepts, major concepts. Okay, they are hard for the next coming topics, of course. Okay, various soft computing techniques you should learn. That is the main objective. The following are the various techniques of soft computing: fuzzy computing, neural network, genetic algorithm, associate memory, adaptive resonance theory, classification, clustering, probabilistic reasoning, Bayesian network. Fuzzy computing, the knowledge that exists in real world in various impressive, uncertain, ambiguous, or probabilistic in nature. This type of knowledge is also known as fuzzy knowledge. Human thinking and reasoning is frequently involves fuzzy information. The classical computing system is to value logic true false. The system sometimes may not be able to answer some questions as human does. Just examine this fuzzy logic with example. Boolean logic and fuzzy logic. Extremely honest, very honest. Sometimes honest, extremely fuzzy logic architecture. Input fuzzifier, rule based, interference engine, defuzzifier. Fuzzy logic architecture consists of the following four components: rule based, fuzzification, interference engine, defuzzification. Characteristic of fuzzy logic: it is flexible and easy to implement. It helps to represent the human logic. It's highly suitable method for uncertain approximation learning. It reviews interference as a process of propagating elastic constraints. It allows to build nonlinear functions of arbitrary complexity. When not to use fuzzy logic, if it is convenient to map an input space to an output space, when the problems can be solved using common sense, when many controllers can do the fine job without the use of fuzzy logic. What are the advantages of fuzzy logic systems? Its structure easy and understandable. It is special for commercial and practical purposes. It helps control machines and consumer products. It offers acceptable reasoning. Acceptable reasoning. If data mining it helps you to deal with uncertainty. It mostly robust as no precise inputs are required. It can be programmed to the situation. When feedback sensor stops working, performance of the system can be modified or altered by using inexpensive sensors. It provides most effective solution to the complex issues. Disadvantage of fuzzy systems. The results of the system may not widely accepted as a fuzzy logic. Is not always accurate. It does not have capability of machine learning as well as neural network, type pattern recognition. Extensive testing with hardware is needed. It is difficult task to extract fuzzy rules and membership functions. Applications of fuzzy logic. I'm posting here applications. Automotive systems. Consumer electronic goods. Domestic goods. Environmental control. Neural computing is again a different category. Artificial neural network, also known as the neural network, is a concept inspired from human brain and the way the neuron is human brain works. It is computational learning system that uses network of functions to understand and translate a data to input one form of to other form. It contains large number of interconnected processing elements called neuron. These neurons operate in parallel and are configured. Every neuron is connected with either neuron by a connection link. Each connection is associated with weights which contain information about the input signal. Components of neural networks. Neuron model. The first one is neuron model. The information processing unit in artificial neural network. Neuron model consists of the following: input, weight, activation function. The second one is architecture. Following different artificial neural network architectures are available: single layer feed forward network, multi-layer feed forward network, single mode with its own feedback, single layer recurrent network, multi-layer recurrent network. Just examine in the below. All these you can examine very clearly in my presentation. A learning algorithm for training artificial neural network by modifying the weights in order to model a particular learning task correctly on the training examples. Following are the different types of learning algorithms: supervised learning, unsupervised learning, and reinforcement learning. Applications of neural network: image recognition, parallel recognition, self-driving car trajectory prediction, email, swarm filtering, medical diagnostics. Genetic algorithm: these are all very important, of course. Genetic algorithm is initiated, developed main theme you should observe in the genetic algorithm. Observe main theme of genetic algorithm. Find here in my presentation. Theme of the genetic algorithm. Just examine the theme of the genetic algorithm. I will post the theme. Just examine here. See the concept and examine the theme. Try to extract the theme here. Initialization is the steps in the genetic algorithm. This is the first step. The next step, fitness function. Selection. Crossover. Mutation. What are the benefits of genetic algorithm? Easy to understand. We always get an answer. The answer gets better with time. Good for noisy environment. Flexible in forming the building the blocks for hybrid application. A substantial history and range of use. Suppose multi-objective optimization, modular, separate from application, applications of generic algorithm, recurrent neural network, mutation testing, code breaking, filtering and signal processing. Applications of generic algorithm. Continuation this and another important presentation is there that we will observe in the next class. Just observe up to this, that's enough. Okay. I want to stop sharing. I want to stop here. Next continuation, important logic algorithms are there. Continue. This is completely based on generic algorithm. That's why you understand up to this. Okay.